Every time you talk to a chatbot, generate an image, or get a reply from a service model in the cloud, there's a high chance a GPU made that happen. But just because a GPU can serve you doesn't mean that they're the final word. Those GPUs are likely built for both training and inference, but we all know that inference isn't really the same as training. It's shaped by different bottlenecks, such as memory, latency, and scale. You end up paying what's called a training tax. So every company asks the question, what's the alternative? Here's one answer, and it comes from the most important startup in Korea right now. Not only do they have the backing from the major players, but the people financially behind it are more important than many of the US competition. They also have a great company name, because who do you need to fight the established market? A rebellion! And that's what the company's called, Rebellions. And they're launching the new Rebel Quad, a high-performance chip we're going to dive into. This is a data center inference processor, and something Rebellions says isn't going to replace GPUs outright, but will serve models better in performance and power by just doing things better. I'm going to show you how it works, the architecture, and why that might matter. In a landscape with over 100 different options, what makes this one stand out? Well, it turns out you have to be a rebel to find out. The Rebellions have started, and this time they brought hardware. So let's talk about what this chip is actually built to do. Rebellions, like so many others, are going after the machine learning that runs every second of every day. Inference. We're talking about serving agentic workflows and responding to users, and quietly doing the work that turns a simple chat prompt into a result, but doing it fast enough, predictably enough, and efficiently enough to matter at scale. At the end of the day, it's all about the metrics that matter for inference: power, consistency, latency, and, in order to deploy, cost. Now that's where most hardware starts to struggle, because inference isn't really one workload, it's kind of two. The first is prefill, where the model digests the full input. That's where you want parallel compute, fast memory access, and high utilization. It's typically described as a compute-bound problem. The second workload is decode, when the model generates its response one token at a time. That's where things slow down, and memory bandwidth becomes the limiter for scale. In many cases, customers buy an extra 8-way GPU box just for the high-speed memory. As I said before, Rebellions is building a chip, or more precisely, a family of chips, under a family name of Rebel. The first one is called Rebel Quad, and is designed to run both phases of the workload smoothly. The SoC looks like this, and it combines 4 chiplets into one coordinated unit that looks like a chiplet-based, but it actually acts monolithic. Rebellions is positioning the chip to offer GPU-like experience, such as 70 billion parameter models per card, but also a better efficiency even at higher performance. But first, let's look at the card itself. I'm here at Hot Chips, and this is the Rebel Quad PCIe card. This is the form factor Rebellions is using to bring their inference chip into real data centers, and it's the first time we've been able to see it up close. You can see the main Rebel package here, the 4-chiplet design underneath this large integrated heat spreader. Next to that are the HBM modules laid out across the board. Rebellions has a number of partners on this side of the design, not only Synopsys for the chip design and EDA, but Alchip for validation and Samsung for the manufacturing. The full PCIe card in this form is designed for about 350 watts, though versions will be available up to 700 watts. You might notice that this card actually has 2 PCIe 5x16 connectors, one to connect into the system, but another for chip-to-chip connectivity. This enables a full 256 gigabytes per second of PCIe bandwidth, but also there's connectivity here for dual 800 gig Ethernet ports, showcasing that scale. They're going to be selling cards, servers, and racks as a go-to-market strategy. And in terms of benchmarking here, they had a system remotely accessed with a number of Rebel Quads running the latest generation Llama models. Now onto that chiplet design. One of the most important architectural choices in Rebel is that it treats the chip as a single slab of silicon. It's built, though, as a system of chiplets, coordinated through a high-speed die-to-die interconnect. Rebel Quad uses 3 UCIe-Advanced channels per chiplet for a total of 12. That's 1 for the HBM and 2 to connect to adjacent chiplets in the 2x2 grid. Now for those unfamiliar, UCIe is the newest chiplet ecosystem standard designed to support an easier way to scale, and if possible, an open chiplet ecosystem where people can mix and match. Rebel Quad is the world's first UCIe-Advanced based AI accelerator, and the team, when I spoke to them, were really proud of that point. The choice of chiplets also allows the team to optimize for known good die, improve time to market, reuse chips, and also bin for higher frequency if needed. All of these chiplets sit on a mesh interconnect in a two-dimensional torus topology, which means that each chiplet connects in a loop both horizontally and vertically. This keeps the average hop count low and helps maintain consistent bandwidth as the system scales. Rebellions claim that that's fast enough to make chiplets behave like one continuous fabric. And also like one continuous fabric, it supports full load store memory semantics across chiplets, which means that the software doesn't have to treat each chiplet as a separate device. The mesh routes the traffic as if it was a single chip system. In this first generation, Rebel uses a priority layer on top of the UCIe-Advanced to keep utilization high, but the physical design is built for a phased shift towards full standard features as they arrive. That means that when UCIe adds extended reach and higher utilization modes, the same topology can scale beyond one package without a redesign. But also, because each chiplet is modular, the architecture is already designed to support additional I/O or memory expanders in future packages. We'll get to that later, because if you hang around, I'll go over what's on the roadmap for future updates later in the video. Now, one of the key design choices in Rebel is how it handles precision. Most inference hardware supports multiple precision formats, often called quantization. This is when we mean 8-bit, 16-bit, even 32-bit. Now, the usual trick here is to pack lower precision values into wider vectors, such as 8-bit values into a single 64-bit vector. It works, but it has its limitations. Each vector runs just one format at a time. You can't switch mid-computation, and under the hood, you often need separate execution units for different types. That technically wastes silicon, complicates scheduling, and leaves hardware underutilized. The Rebel Quad takes a different approach. It uses a unified mixed precision compute engine, where each operand can be configured independently, but still run through the same data path. You don't need to separate cores for FP8 and FP16, the core adjusts on the fly. The result is tighter data packing, simpler scheduling, and higher utilization, especially on real workloads where the optimal precision can vary layer by layer or even token by token. At the heart of each chiplet is a wide issue scaler engine. This isn't a GPU-style vector unit. Instead, it issues multiple independent instructions per cycle, managing both tensor and vector math across a large number of cores. The execution is hardware managed, designed for throughput without relying on software scheduling. That wide issue design helps sustain performance when workloads shift or memory stalls occur, while the mixed precision data path avoids costly reconfiguration between the AI model layers. They claim Rebel Quad can deliver up to 3 times the performance per watt of comparable GPUs, and in total around 2 petaops of dense 8-bit floating point throughput per package. They also argue it can sustain that throughput under real model workloads because the architecture is built to mix, match, and keep issuing instructions without stalls, wasted cycles, or format overhead. Now, they have a point here. When you're decoding long contexts under load, sustained performance is really what counts. Now, one of the key aspects of inference is memory bandwidth, and the Rebel Quad is designed to take advantage of lots of memory as close to the compute as possible. This chip enables tight coupling between the arithmetic units, register files, and 4 megabytes of scratchpad memory per neural core, plus another 64 megabytes of L2 memory per chiplet. Cores can move data directly into a neighbor's scratchpad via a neural DMA engine. DMA in this case stands for direct memory access, which reduces costly round trips even to high bandwidth memory. That matters during decode where memory access patterns become irregular and context dependent. The DMA itself is predictive and software tunable. It anticipates which data needs to move and places it directly where it's required. Developers can also use it to set task-level quality of service, reducing latency spikes and smoothing out performance across batch sizes. The fabric itself provides 2.7 terabytes per second of effective bandwidth across the cores, plus 1.2 terabytes per second of direct HBM access per module. Chiplets are linked by 1 terabyte per second die-to-die connections with just 11 nanoseconds of latency per hop. Now, a hardware demo is compelling, but inference at scale only works when the software stack is built with the chip in mind. Rebellions has developed its software development kit in tandem with the silicon. This approach, from compiler through runtime, is designed to deliver full-stack inference performance. The official documentation today promises seamless support for frameworks like PyTorch, VLLM, and Triton, with over 200 reference models including Llama 3 and Stable Diffusion XL pre-optimized to run out of the box. We do expect more to follow. Under the hood, the compiler breaks models down into an intermediate representation, then applies partitioning, operation fusion, tiling, and weight serialization to match the compute cores and memory layout of the chiplets. That command stream then directs the hardware for execution. The compute library in the development kit contains hundreds of optimized operators, such as gems, normalizations, and activations, all tuned for inference workloads and hardware flexibility. And the runtime module handles program sequencing, data movement, and real-time performance tracking during execution. Interestingly, Rebellions joins the PyTorch Foundation and has native PyTorch 2.0 and torch.compile support built into the software kit, letting developers use model acceleration directly in their training to serving pipelines. They are also working closely with the VLLM framework to enable the integration of continuous batching, flash attention, and page attention optimizations into their stack. That combination should improve memory efficiency and latency for LLM decoding workflows. Another notable point is task-level control over memory quality of service. Rebel's software stack exposes the predictive direct memory access engine, not as a black box, but as a tunable system where developers can prioritize latency-sensitive tasks, shape background traffic, and avoid tail latency spikes. That's a level of runtime control you don't typically get in GPU-style inference stacks. And beyond developer tooling, the stack also includes APIs that let operators integrate directly with modern deployment platforms, such as container orchestration through Kubernetes, VM-based provisioning, and health monitoring hooks for large-scale services. There's also a focus on reliability and serviceability, with RAS features built into the runtime to catch, report, and recover from hardware faults without taking workloads offline. Okay, you've been waiting for it. Let's pivot to the exciting part, the roadmap. As mentioned at the start of this video, Rebel is a whole family, and while Rebel Quad is the initial flagship, it's not the end of the story. Rebellions has already announced 2 more chips, Rebel I/O and Rebel CPU. Next year, Rebel I/O combines Quad with new silicon designed to connect accelerators to CPUs and memory without becoming a bottleneck. This is a low latency, high bandwidth connection to support data center level interconnects. It uses the same two-dimensional torus topology as Rebel Quad, extending that network across cards into racks. That topology keeps hop counts low and helps maintain predictable bandwidth as systems grow. Combined with 800 gig Ethernet running Rocky V2, it is designed to link racks into superpod scale clusters with minimal latency. Now in 2026, we get the evolution, Rebel CPU. This takes the Rebel I/O chip as a baseline and then changes one of those I/O chiplets for a CPU chiplet instead, to enable more complex large-scale AI. It's part of an ARM flagship initiative built on Samsung's SF2P process and links to the NPU with under 60 nanoseconds of die-to-die latency. The design sits alongside the accelerator, running orchestration, control logic, and potentially pre-processing or lightweight inference workloads. While the CPU market is crowded, Rebellions is focusing on tight integration with their own stack. That means fewer translation layers between components and more predictable system behavior at runtime. Owning the I/O and the CPU gives Rebellions control over the full inference node, but also allows customers to adapt if they want their own host or to scale out the system with Rebellion's solution. With all that, let's take a step back for a second. It's important to position this chip in context of the company itself. Rebellions has a lot of history behind it for what could simply be described as a Series B startup. This is a team that has raised more than $200 million, backed by some of the most strategically aligned investors in the AI and semiconductor ecosystem. Their backers and partners include Temasek, Korea Development Bank, Pavilion Capital, Korea Telecom, SK Hynix, Samsung, and Aramco. This is a mix of global funds and some of the world's biggest infrastructure players, which gives the company both financial scale and deployment leverage. So often we call out US companies for having localized top-tier venture backing, but for a chip startup outside the US, these names are incredibly significant. They provide real weight for not just chip design, but also go-to-market opportunities. Now, Rebellion's previous chip, called Atom, and specifically the upgraded version Atom Max, is already in mass production and deployed inside South Korea's largest telco, providing high-volume AI services for its customers. Partnerships are already underway with NTT Docomo, IBM, and others. That kind of customer traction is rare at this stage of a Series B, especially for a company competing in the accelerator market.
So I know, there are many, AI company out there, right? So what we actually differentiate ourselves against them is we actually, try to, outpace them through the, scalable architecture. So we actually, use scalable SoC design and also the chiplet solutions. So with them, we can actually build different, type of accelerator to the market more in a fast pace and delivering better performance and better energy efficiency compared to them. So I totally agree with your point that, AI market or a trend is kind of headed to the system or rack scale solutions, right? That is the reason why we are actually collaborating with the different system companies or, solution company that could handle, multi-rack scale AI infrastructure, right? So one of the good example is Marvell, right? So we're talking to Marvell and to build a, next generation AI accelerator and AI infrastructure together. So what you see from the market is if you really want to squeeze all the performance gain that you can get from the infrastructure or energy efficiency gain from your system, then you have to actually build a whole system with a holistic view, right? So in that sense, I think Rebellions or any other accelerator have to focus on building, whole entire stack together with kind of that holistic view, right? So they are really satisfied with its quality and also the performance, right? So the Rebel Quad is definitely, I can tell that it's if you look at the spec of it, it's a H200 compatible. So the number of computation unit that it put in the accelerator or the memory capacity or bandwidth, this is a kind of an accelerator you can't easily find from the market right now, right? So that's the reason why many neo cloud company or big enterprise company or even hyperscaler are waiting for our accelerator. So I definitely read a high expectation on it, and also so far it's running pretty well, delivering good performance and energy efficiency.
So, despite this breakneck speed of development and deployment, Rebellions is getting even bigger. In late 2024, the company completed a merger with Sappion, another Korean AI chip company backed by big names for the region. Sappion had its own roadmap, its own team, and its own customer relationships, as well as important investors. The combined company brings together talent, IP, and manufacturing scale with a clear mandate to become Korea's national AI hardware champion. To emphasize that point, Rebellions recently finished a Series C funding round, raising $250 million. Part of this includes strategic backing from Arm to accelerate the roadmap. Unlike many US-based startups that end up building around a small number of domestic cloud partners, Rebellions is positioning for broader infrastructure. The idea is they're not limited to one hyperscaler's software stack or data center footprint because they have to work domestically, regionally, and globally. Because they're based in Korea and are the sole unicorn silicon startup in the country, they have direct access to a deep pool of system integrators, foundry services, and memory supply. They include Samsung and other investors. What makes this all more interesting is that Rebellions is not trying to sell compute cycles to the biggest players in the world. They are trying to give everyone else a visible alternative. That includes regional cloud platforms, sovereign infrastructure programs, and enterprise AI deployments that want their own stack without building it from scratch. So one of the things I like about my job is that I get to travel the world and see the latest silicon being made. For any US-based company, that's pretty straightforward, especially when they want to talk about their product. It's a bit more difficult if the company is quiet or they're based outside the US. Rebellions would normally be one of those, but I've seen them at a number of conferences already, especially with previous generation hardware. So when they reached out to me about doing a video on Rebel, I had a couple of requirements, but the main one is to actually see the chip in person and understand how it works. This is because Rebellions is in a tough market. There are a number of high-quality inference-focused data center accelerators coming to market. Some rely on building the networking into the chip, others dance the difference between memory types. The new Rebel Quad chooses its direction not because it's easy, but because they believe there is a market with a need and they have a solution. With the investors and partners they have, there are a few companies better positioned to succeed. Going back to the chip for a second as a recap, Rebel Quad is a 350 watt PCIe card that will offer variants up to 700 watts. It's 4 chiplets connected over UCIe-Advanced with HBM3E and high-speed memory bandwidth. Inside each chiplet are neural cores featuring mixed precision engines to boost compute density and a compute near memory designed to improve utilization. There's lots of memory bandwidth, lots of peer-to-peer. There's a DMA engine that helps with data. It even does predictive DMA, and that's really interesting. They quote 2 petaops of 8-bit performance per chip with high utilization compared to GPUs from Team Green, enabling better performance per watt and better total cost of ownership. Now, I know this audience, and one of the first questions is going to be, where can we buy one of these? A PCIe card should be easily available, right? Now, you all know I'm a big fan of getting cards into the hands of people like you and me as easy as buying a card from Amazon. But it's becoming increasingly clear that the more companies in this space I work with, any card with HBM on it, especially high-speed HBM3E with advanced packaging, simply won't be price-friendly enough for us to buy on a whim. Now, I did the cost analysis on the bill of materials for one of NVIDIA's B200, and at cost price for HBM3 on that card, let alone the silicon, the memory itself was probably around $3,500. That's before packaging and before margins. And that's why going down the HBM route, like what Rebellions have done, is a gamble given the cost and supply requirements. But it does mean we're unlikely going to see a Rebel quad with a buy it now anytime soon. Nonetheless, for businesses that are interested in testing Rebel quad, you should reach out to get access to the hardware and the system. The chip is right now ramping up for production, and the first ones are already up and running as we've seen. Rebel is one of the few chips that has enabled infrastructure programs that cannot rely on a US or China-centric supply chain. It's easy to forget how much of this industry is still concentrated in those handful of places. What Rebellions is building, and where they're building it, makes a pretty strong case that the next phase of AI hardware is going to be a lot more global than the last one.